to changes in climate through their traditional knowledge systems as they've done for centuries. Traditional crops and livestock breeds themselves are the product of traditional knowledge developed and conserved through traditional farming systems. And then there's a knowledge about wild crop relatives used for plant breeding, livestock domestication. Traditional farming practice that are resource conserving, maintaining ecosystem services, and traditional knowledge of forecasting weather and monitoring local changes. Change, next one. Just to quickly outline a study which was done in 2010 in the southwest China, coastal Kenya, Libyan Andes. I'm not going to go through the methods because we're running out of time, but they all involved field research in a number of sites in different indigenous communities. There's a briefing paper at the back, Adapting Agricultural and Traditional Knowledge, where you can get more information. Next slide. In all three cases, the key critical factor that has enabled adaptation to quite extreme climatic events, like drought, pests, rising temperatures, etc., has been the diversity of local crop varieties. Diversity provides a gene pool for selecting new varieties with different environmental effects, and local varieties often have more resilient genes because they're more genetically diverse and they're adapting constantly rather than modern varieties which have been bred for uniformity. So I'm going to move on to the next slide. The other advantage of traditional crops is that they're cheap and easily accessible, so it's important for poor farmers in rural areas who can't afford or don't have access to modern seeds. And a really important thing to note is the importance of seed networks and wide seed exchanges between communities and not across landscapes. And this is going to be increasingly critical with climatic changes to allow communities to adapt to access new varieties. So those social networks across landscapes really need to be strengthened because they provide access to new seeds needed for adaptation and food security. Next slide, please. Another study we did found that traditional knowledge and agrobiodiversity are very much dependent on landscapes, customary laws, cultural and spiritual values. Thank you. Anyway, well, this is the last slide. So a few suggestions what we need to do. Unfortunately, there's some seriously worrying trends, a very rapid loss of traditional knowledge and agrobiodiversity occurring in these biocultural rich areas, which is so important for climate change adaptation. And one of the biggest drivers of this is agricultural policy, research, and intellectual property rights, which promote the spread of modern varieties at the expense of these remaining centres of genetic diversity. But there's a real need to secure the land rights, natural resource rights, the traditional knowledge and the seed rights of these communities to enable their adaptation processes to continue. And I think given the speed and extent of climatic changes that we're likely to face in the future, we really need to think about what the best way to address these extreme changes will be to combine ecosystems and traditional knowledge and science. I think we need all of these together. A great example of that is participatory plant breeding, which Yuqing is going to talk about in China. Really important to support local seed systems, as I said before, local initiatives like community seed banks, seed production, seed networks, markets for traditional crops. And finally, obviously improve the evidence base, as I said at the beginning. IID and partners are about to launch a new 5-year research project, well, have just launched, called Smallholder Innovation for Resilience, Strengthening Innovation Systems for Food Security in the Face of Climate Change, in India, China, Peru and Kenya. And we're going to be working in some of these centres of biocultural adaptation, to identify innovations, to conduct some inventories with the local communities, to identify innovations that are useful for adaptation and to help spread them in the local areas, but also to document them and provide evidence to inform food security debates, agriculture debates, that these traditional varieties and traditional knowledge systems are incredibly important for adaptation. So unfortunately I can't share the findings here, but it will involve a literature review to review the evidence base, field studies and developing tools to strengthen farmer innovation systems in these areas.
Thank you very much, Christina. I'd like to welcome the next speaker now is Dennis Rowe, also from IIED. She's a senior researcher there. And she's going to talk about, those talks entitled A Review of the Current Evidence for EBA Effectiveness.
Thanks, Dave. First of all, I'd just like to say that I'm presenting this on behalf of colleagues from WCMC, BirdLife International, and from the University of Cambridge. And we worked together on this systematic review project. And I have to say that particularly colleagues from WCMC and BirdLife deserve most of the credit for this. They were the ones that undertook the bulk of the reviewing, which was no mean feat. Systematic review study is not the kind of thing to enter into lightly, I think, was one of our lessons learned. Okay, just to give you a bit of background as to why we went about this study. One of the main arguments for EBA is that it's effective, and when people say that it's effective, they mean that it does what it's supposed to do. It increases the resilience of a community, or it provides flood protection, or it addresses some other kind of adaptation target. It's also, given some of the uncertainties of climate change, it's also considered as a no-regrets option that avoids maladaptation. And then on top of that, it provides numerous co-benefits, not least biodiversity conservation. It's also thought to be cheaper and more cost-effective than hard infrastructure options. But what we were looking into was what's the evidence that this is really the case. Most of the literature on EBA provides very little substance behind these assumptions. There's lots of anecdotal evidence, lots of case studies, displaying that local people are using biodiversity and ecosystem services to adapt, but there's very few quantitative studies, there's very few with any kind of control situation or counterfactual or before-after analysis. Particularly there's very few studies on cost effectiveness that really look into the economics of EBA. And to date there's been no systematic synthesis of the literature that's out there. As Dave mentioned in his introduction, if policymakers really want to make informed decisions about what's the best approach to adaptation in any particular context, and they need better evidence on the costs and benefits of EBA versus other options that may be available to them. So clearly there's a need to improve the evidence base, but before this happens we need to know what information is already out there and how much of that can be useful to inform the debate about EBA. Much has already been learned about how you cope with climate variability and extremes, and this is coming from the fields of disaster risk reduction, drylands management, community-based natural resource management, and so on. Activities that have been going on long before we started labelling anything as EBA. So our study was really intended to address this issue, reviewing the existing evidence base in order to identify the key gaps and drawing on literature from a wide range of disciplines. So our study methodology, as I said, we adopted a systematic review approach. This is quite a sort of tightly prescribed methodology. It focuses on the fact that it has to be well documented and replicable by other researchers. So you have to very clearly document in a research protocol your search terms, your sources of evidence, your criteria for including or excluding certain kinds of evidence, and so on. And the question that we were trying to address in this review was what evidence exists regarding the ability of ecosystem-based approaches for adaptation to help people adapt to the impacts of climate change, and then secondly, what are the critical knowledge gaps in the evidence. So we reviewed 132 journal articles and 32 grey literature case studies. These weren't just general papers about EBA. One of our inclusion criteria was that they had to specifically address the issue of effectiveness. And I think this doesn't sound like a huge number of studies, but I think that's quite telling in itself how few actually really looked at effectiveness. We got down to our 132 journal articles from an initial, when we did our initial search, we identified 7,000 in total, and we narrowed that down to 132 that really tried to explore effectiveness. Again, in terms of sort of the scope of the study and linking to the spectrum that Dave set out in his introduction about biodiversity first or people first, we were very much focused on studies that were focused on people, about how people adapt to climate change, rather than looking at those that were about biodiversity adapting to climate change. We developed a standard framework for interrogating our evidence, which is essentially a questionnaire. But again, because this is systematic and replicable, it's a standard set of questions which we apply to every single journal article and case study that we looked at. And we were asking questions for these studies that have looked at effectiveness. What kinds of climate hazards and impacts have they looked at? What kind of ecosystem types have they focused on? What kind of adaptation targets, and so on. So we weren't aiming to determine specifically, to answer the question, is EBA effective, but to report really on the extent and the description of the evidence to date. So these are our results. I'll run through these really quickly. This is just to give you an idea of the geographic coverage that studies that have addressed EBA effectiveness come from. So there's a roughly equal split between developed and developing countries, but you can see there's an awful lot coming from Europe, and a surprisingly limited number from other regions of the world. These were the ecosystems that were being addressed in the studies. This typology of ecosystems is drawn from the IUCN habitat list, which had been modified by BirdLife International for application at their IBA sites. And as you can see, the majority of studies, I think this is quite surprising, came from this category called artificial terrestrial landscapes, which basically is converted landscapes. It covers agricultural land, plantations, urban areas, and so on. There's also quite a lot from forests and from wetlands and coastal areas, but surprisingly little, we thought, from other kinds of ecosystems. These were the main climatic hazards and impacts that were being addressed. And as you can see, there's a big focus on loss of biomass cover and biomass productivity, also on droughts and on flooding and water quality impacts. And these were the main adaptation approaches that the literature focused on. Again, mainly focusing on how to promote biomass growth and protection, regulation of water storage, runoff and flooding, and disaster risk reduction. This graph shows you the number of studies that really consider the costs and benefits of EBA, and one of the slightly disturbing findings from this is that lots of studies looked at the benefits, not so many considered the costs. Somewhere in between the green ones and those that looked at both. I won't address this. This is a table that shows the broad kinds of costs and benefits that the different studies addressed. All these results are summarised in a briefing paper at the back and in a more detailed paper that we're in the process of writing up. So, to get to the point, is EBA effective? What did our study tell us about this? Before we can answer this, we need to define what we actually mean by effectiveness in the context of EBA. And that, again, there's no one single definition of this, but the one that we liked the most was a paper by Dorio et al. In 2009, which was based on expert opinion as to effectiveness, and it defined it as this: adjustment that reduces risks associated with climate change or vulnerability to climate change impacts without compromising economic, social and environmental sustainability. On this basis, tentatively, we reckon that the evidence base overall says yes, in that the majority of the studies that we looked at demonstrated a positive result in terms of effectiveness. However, and this is the key issue, there were major shortcomings in the evidence base. Dave covered a lot of these in his introduction, and I promise we didn't confer before we talked, so it's quite interesting that we're coming up with the same things. First of all, a very limited comparisons with any of these studies that talked about effectiveness, comparing this with alternatives. You know, how this is effective, but how good is it compared to the best possible alternative? Particularly studies that took into account social, environmental and economic considerations. There were very few studies which looked at thresholds, boundaries and tipping points, so they could look at, say EBA was effective in this particular context, but they didn't really consider what the limits to that effectiveness were in sort of biophysical terms, in terms of boundary conditions and tipping points of sort of levels of climate change or levels of degradation. Very little attention paid to costs, as I said, rather than just benefits. Very little attention given to temporal and spatial aspects of effectiveness. So, you know, this might not be effective now, but it could be really effective in 10 years' time. That's when the benefits start to be reaped. Or vice versa. This looks like a good option now, but it's not really sustainable over the long term. Very few studies that considered those kinds of effects or downstream effects. And our overall conclusion was that we could really help improve the evidence base if there was much more strategic monitoring and evaluation of existing EBA projects, so that when you're setting up your project, you really start thinking about these issues of what are the costs as well as the benefits. What's the economic side of this in terms of effectiveness, and all these issues that I've identified here. Some consideration in projects that we're developing from now onwards as to thresholds, temporal and spatial effects, and so on. I think this kind of study can really help inform the M&E framework for future projects. Thank you very much.
Thank you very much indeed. Do you want that paper is coming out? The description of...
Well, the summary paper is already available. We're just submitting the full results paper to Global Environmental Change, so it depends how quickly it gets through the peer review process.
Thank you, Dilys. So before we go into the next session, which is the actual field program, so hearing from the field, we probably don't have time to try anyway for literally just a couple of questions if you have for any of the first three presenters. Go with Keith there to start with.
Thanks, very good presentations. Several people highlighted the need for monitoring and evaluation especially the last speaker. I guess I have a question, which is, has someone done similar studies for engineered and hard options, monitoring their cost effectiveness over long term? And is there, to some extent, a political risk if we highlight too much the obvious need for this in EBA without recognizing this is something that's true of all adaptation, this need?
Dilys, you want to take that?
The answer to the first question is I don't know whether a similar study has been done to hard adaptation approaches. I would assume not. We certainly didn't find any that compared. And yes, I do agree it's a risk, but if we just say this does make it look like it's just the evidence base for EBA that's weak, when it's probably weak on all adaptation approaches. So maybe we need to, yes, counter our message with the need for better evidence on adaptation approaches all round.
So we have time for just one more. I apologise, there's a gentleman at the back here who's got his hand up fast.
I have a question for the presenter on the ecosystem and traditional knowledge in adaptation. I would like to know, given the wide and diverse geographical coverage, did you try to find out the differences or similarities in the way indigenous knowledge is stored and transmitted?
We did look into that. We looked at mostly the relationship between traditional knowledge and biodiversity. So it wasn't a comprehensive We didn't study the role of language or other factors, but we looked at the role, because we started the project by, it was a project about protecting traditional knowledge, protecting rights. But we started by thinking, well, we need to look at traditional knowledge in the way that Indigenous peoples looked at it, as a holistic system that's linked with biodiversity, landscapes, customary laws, cultural and spiritual values. So we looked at those elements of this sort of Quechua Indigenous worldview in the ground in many different locations. And in practice, we saw that these factors were indeed very important for the transmission and maintenance of traditional knowledge, the use of biological diversity in sustained traditional knowledge, landscape sustained cultural values, which in turn brought a really critical incentive to sustaining agrobiodiversity, which is critical to sustaining traditional knowledge. And all these factors are really interdependent on one another. It's like that's why we call it a biocultural system. Does that answer your question?
Thank you. I know there's a lot more questions potentially. Can you sit on them? And what we'll try and do, and this goes to the next session, is